So for our project, we know that in class we learned how to model mass spring systems, and when we find the solution to that differential equation, we see that it's sinusoidal, and we also learned in physics that when you look at a single point on a wheel as it rotates about, if you look at one dimension, then that point also oscillates in sinusoidal motion. So we thought it'd be cool if we could figure out a way to show the relationship between two very different systems with the same sort of function.
Alright, so here we have our mass spring system, which we are suspending exactly 1 kilogram from. And over here on our wheel, we have this blue indicating flag right here, which is going to kind of oscillate between this mark and this mark. And on our spring, we have this blue line on this bucket, and in the equilibrium position, it's perfectly in line with the axis of the wheel. And as it goes down, we'll line it up with this mark, and as it reaches the top of its amplitude, we'll line it up with this mark. So to help us sync the two periods of these two systems as they begin to move, we've embedded a little bit of electronics. So we're using an Arduino micro and a LCD readout, along with two photo gates, which are basically an LED paired with a photoresistor. So as you can see right here, this LED is shining on this photoresistor. It's going to the Arduino. It's picking up a certain light level. When the bucket breaks the path of the LED, changes the level on the photoresistor, the Arduino can sense that that's happened, and then that starts a clock, which basically keeps counting until the path gets broken again. And that counts one period for the spring motion. Similarly for the wheel, we have cardboard masking out the spokes of the wheel, except for this one gap right here. So every time the wheel spins a complete revolution, the light can basically shine through this gap and hit a photoresistor that's mounted into this 2x4 here. So again, uses a similar clock cycle to count basically the period of the wheel. The Arduino is taking those two periods and printing them out to this LCD screen, so it makes it easier to match the two periods, make sure they're exactly the same. And when they are exactly the same, and when they have the same phase of motion, the two systems, well, you should be able to observe the exact same sinusoidal oscillation of the blue line on this bucket and the blue indicator flag on this wheel. So just to give you a little close-up of all the electronics, this is our Arduino here and our LCD screen, and these wires that kind of go over the back hook up to our LED, which you can see there, and it's shining a spot, and then when the gap on the cardboard goes by, you can, well, that little hole right there, the photoresistor is mounted in there, so as you spin the wheel, the light sweeps across that. And down here, we've got our LED and our light sensor over here, and as the bucket goes down, it puts it in shadow and trips the photo gate there. You'll notice that we have this K up here too. That's actually the spring constant of the spring, which we're calculating from the period of the wheel. So it's pretty reliably been about 40 newtons per meter, I think. So right now we're calibrating the photoresistors so that they can accurately count periods. Basically have a function that averages the light level over 5 seconds and sets that as the baseline. So you spin up the wheel so it spins faster than it should, and then you wait for friction to slowly slow it down to the correct period, and then once it's at the correct period, you let go of the bucket. And for a second there, before the wheel slows down even farther, you get the exact same motion.